Continuing lesson 4.4 with factoring, we are looking at factoring a difference of two squares here. What makes it a difference of two squares is that the first term here is a perfect square, the second term is also a perfect square, and you have a subtraction separating them. So if you have a difference of squares, you can factor by taking square roots. So the square root of 25x squared would be 5x. And the square root of 49 is 7. So 5x times 5x would give us 25x squared. 7 times 7 gives us 49. And then to get the negative here, we have to have one positive 7 and one negative 7. When you FOIL this, the outside gives you negative 35x, the inside gives you positive 35x, so the middle term actually cancels out or equals 0, which is why we only have a binomial here. Okay, you try the next one, and when you're done, hit play. Sticking with our theme of perfect squares, we're back to trinomials, but we have trinomials with a leading coefficient. In this particular one, we could factor out the GCF. I guess we'll go ahead and do that. We'll factor out our GCF. So if we factor out the GCF, we have x squared minus 6x plus 9. Okay, but what remains here is still a perfect square. X squared is a perfect square, and 9 is a perfect square. So if we were to factor that as square root of x is x, square root of 9 is 3, this time we want 3 to come out positive, so plus 3 would give us plus 9, but it needs to be negative in the middle instead of canceling. So if we go minus 3, this will give us negative 6x when we do outside times inside, and positive 9 when we do the last times the last. Okay, our next example here, we cannot factor out a greatest common factor. We still have a leading coefficient, but you should notice that 64 is a perfect square. 1 is also a perfect square, so we can factor this by taking square roots. So square root of 64 is 8. Square root of 1 is 1. And if we multiply a negative times a negative, we'll get the positive 1 here. And when we multiply outside, we get negative 8x. Inside, negative 8x. That adds up to our negative 16x, which is the middle term. So, to summarize, if the leading coefficient and the constant term, let me draw a picture here, if the leading coefficient and the constant term are both perfect squares, you can usually factor by taking square roots and putting them in your 4 positions. Okay, now this is going to be the hard part. We want to factor this expression where we have a leading coefficient that is not a perfect square, and it also, you cannot factor out a GCF. So when you go to factor this, you're going to have your binomials, but the first 2 positions aren't automatically x and x, or square root of 2 and square root of 2. So it's much more complicated. So what we're going to do is we're going to factor by using this tic-tac-toe method. In the tic-tac-toe method, your first term is placed in the middle. The last term is placed in the bottom right corner. And then you multiply these 2 terms together and you make a list from this. So we want everything that multiplies together to make 24x. So x times 24x squared will give us 24x squared. 2x times 12x gives us 24x squared. 3x times 8x, 4x times 6x. So this is similar to how we were factoring earlier. Now we look at our choices, our 4 possible choices, and we want to find the one that adds up to 11. Well, 3 plus 8 is 11, so those two terms will go in these two boxes. Those two boxes can be switched. You can put the 3 on the top and the 8 on the bottom. It doesn't matter, but the 3 and the 8 will go in those two boxes. Once you have the numbers in the boxes, then you will factor out a GCF for each row and each column. So going across this row, the GCF for 3x and 12 would be 3. Across this row, the GCF of 2x squared and 8x is 2x. And then we'll do the columns. The GCF for this column is just x, and the GCF for this column is 4. These values that we have are our factors. So the factors of 2x squared plus 11x plus 12 are going to be 2x plus 3 and x plus 4. If we FOIL this, we should get our trinomial. So 2x squared times x gives us 2x squared. For the outside, we have 8x. Inside is 3x. Adding that together gives us 11. And then finally, 3 times 4 gives us 12. So it's a little bit complicated. Watch the video a second time if you need to. And then we'll do problem B. Okay, for problem B, we're going to set up the tic-tac-toe because we have a leading coefficient. The leading coefficient is a perfect square, but our constant term is not, so we know we're not factoring a perfect square trinomial. So the 4x squared will go in the middle, negative 3 goes in the bottom right corner, and we multiply 4x squared times 3, and we get negative 12x squared. Now we make the list for everything that multiplies to make negative 12x squared. So we can have negative x times 12x, or x times negative 12x. And 2 times 6, or the 2 could be the negative 1. 3 times 4, where one of them has to be negative. And from this list, we're picking the one that adds up to negative 4x, because that's our middle term here. So the one that adds up to negative 4x is 2x and negative 6x. So we put those values in the two squares. Oops, that's positive 2, negative 6. And then we take out a GCF. So the bottom row has a GCF of negative 3. Top row has a GCF of 2x. First column has a GCF of 2x, and the last column has a GCF of 1. So 2x squared minus 4x minus 3 will factor as 2x minus 3 times 2x plus 1. And you can check that by FOILing, and it should work. Here are some problems for you to try, and that ends this lesson.